everyone. So today we're looking at lesson 8.8, and this may or may not be in order in your packet, so make sure you're looking at the correct page here. Lesson 8.8 is on solving equations with radicals. That's good news because we're going back to the land of equation solving, and you guys are really good at equation solving, okay? But there is one really tricky, very frustrating thing about this lesson, and that's this word right here, extraneous solution. So you'll want to get this definition down at some point, but I'm going to kind of explain what it's talking about. Extraneous means unnecessary or extra. And so what happens with these equations sometimes, and it has to do with all of that, restrictions when things are negative and, you can only have odd roots in this situation. All of those kinds of things can lead to problems when we're solving equations. And so it's possible to do a problem entirely correctly. All right, you've taken every step correctly. You can feel really confident about it. And then you get to the end and you plug your answer back in and it doesn't actually work, okay? And in that case, we end up just throwing our answer out and saying it has no solution. But it's frustrating because we've done all of the work to get to that answer, and it's not like we made a mistake, okay? So an extraneous solution, again, is something that arises through correct methodology, meaning you did all of your steps correctly, but it still doesn't make the equation true. And it has to do with all of those crazy restrictions. And that's hard for us sometimes because I think some of us have gotten so good at equation solving that we've ditched the habit of checking our answers. When we solve 2x plus 1 equals 5, we don't feel the need to check our answer on that because we're pretty confident we know how to solve that. Okay, this is not about confidence. This is not about being good at equation solving or bad at it. You just have to get in the habit of checking every single one. Luckily, we can check them in our calculator, and I'm going to help you type them into your calculator correctly. But that's really the only thing that's kind of crazy today. Okay? So, whoops, you don't want that. I always click the wrong thing here. I just want to make this go away. There we go. Okay. So taking a look at this first one, this one's pretty basic. Cube root of x equals 5, right? To get rid of a root, we're going to use a power. Roots and powers cancel each other out. If you think back to like solving something like this, where you have a power, we always used a root for that. We always said, okay, a cube root is going to cancel with a cube. This is just going the other way around, okay? This is starting with the root and saying we're going to use a power to cancel that out. Roots and powers are inverses of each other. But that means that I have to raise this to the power of 3 as well. Okay, x to the 5/3, or 5 to the power of 3 would be 125. Okay. And then, like I was just ranting about a second ago, we do need to check our answer. So this is one of the older styles of calculators, so watch what happens when I type this in. 3, and then x root of 125. If your calculator screen looks like mine right now, you have what I keep referring to as the older style of calculator. Okay, there are going to be some things that look different on the older style versus the newer style of calculator, and I have both here. I'm going to show you both. Okay, but just be familiar with what calculator you have, and I would suggest, even though I realize you're just watching a video, that as I'm doing things on my calculator, you do them along with me, so you get used to typing these things in, okay? But anyway, we came out to 5, which is what we wanted to come out to, so that means that our answer checks out, okay? 125 is a valid answer here. So looking at number 2, before I can do anything, I want to get rid of any junk that's on the outside of the radical, so let's divide by 2 on both sides. And so I get the 4th root of g minus 5 equals 5. Sometimes we stumble a little bit on what to do next. Do I add the 5 or do I get rid of the 4th root? The 5 is inside the root, so I can't do anything with it until I get rid of that radical sign. So my next step would be to raise to the power of 4 and raise to the power of 4 over here so that I can cancel out that whole root. And now I have g minus 5 equals 5 to the 4th is 625. Okay. From there, add the 5 to both sides, and I get g equals 630. and then I'm going to type this in and check it. This is one where it looks different on old calculator versus new calculator, okay? So on the older style of calculator, let me just make sure I can see my problem here. I'm going to type in 2 times 4 and then x root. But you see on this one, it just kind of sets the x root there, and you can just keep typing. In order to tell your calculator that the g minus 5 all belongs inside the radical, you're going to need parentheses around it. So you're going to say 630 minus 5. And this is how you tell this calculator that that root applies to all of this. Okay? And we get 10, which is what we wanted to get. That's awesome. Now let's see what that same thing looks like on this calculator. 2 times, and then I'm going to do the 4 with the x root option. But notice on this calculator, it goes ahead and puts the 4 in the right spot for me, and it puts my cursor underneath the radical there. That's going to allow me to just type and keep everything under the radical like we want it. Okay, so on this one, I don't need the parentheses, and I also come out with 10. Okay, so both of these check out. We're good to go. This is a good answer. Okay. For the sake of time, I'm actually going to skip over number 3 and go straight to number 4. My classes that I taught, that were not blended, we skipped over that one and we were just fine. So I'm going to go down to number 4. Okay. So number 4, let's get rid of this 3 first. That is a positive 3, so I'm going to subtract and subtract. And I end up with negative 4th root of y equals 7. Remember that negative sign is really like a negative 1. So divide by negative 1. And I end up with a 4th root of y equal to negative 7. And then I'm going to raise to the power of 4. Oh, excuse me. Remember when I do that negative 7 raised to the power of 4, I'm going to need to put that in parentheses. I don't remember what that is. I think it's 2401. Yep. And so I get y equals 2401. Okay. And then I'm going to check. Okay. So here's my calculator. Let's go over here. 3 minus the 4th root, so 4x root of 2401. And we're hoping that it comes out to be 10. And it does not. So notice I did not get that answer, okay, that I was supposed to get. I did everything correctly. There are no mistakes made in my methodology here. Everything was a legal mathematical move. And still my answer doesn't work in my original equation. So my only option when that happens is, unfortunately, to cross this answer out that we worked so hard for and just say no solution. Okay? You do have to look out for those no solution problems. Okay, they're not going to happen a lot, but they are going to happen sometimes. Okay, and then number 5. Number 5 is a tough one because a lot of people would look at this one and not really know where to start. And there's one even on the homework that's very similar to this, but even after doing number 5, I still had a lot of questions on, well, how do I start a problem like this? So I'm going to make a suggestion that you think about an easier version of this problem to start you out. Pretend you didn't have any crazy radicals in there, and this problem just said this: g plus 9 equals 4g. Okay, pretend I was just working with this equation. All I did was take out the roots. What's the first thing we would do? I would probably subtract the g from either side. And so now I have 9 equals 3g. 4g minus 1g gives me 3g. Divide by 3, and then 3 equals g. Well, that wasn't so hard, okay? This problem actually works just like it, all right? Instead of starting by subtracting a g, I'm going to subtract the 6th root of g and subtract a 6th root of g. Because I need to somehow get my g's together, right? So I only have one of them to isolate. So this is gone now. Now I have 9 equals Remember, this is 1/6 root of g. So if I have 4 of these ugly things and I take away 1 of these ugly things, that leaves me with 3 of these ugly things. Okay? So don't let that subtraction bog you down. You have 4 apples, you take away 1 apple, you're left with 3 apples. Okay? Same idea. And then just like when we were at this step, next I'm going to divide by 3, and I'm left with 3 equals the 6th root of g. I'm going to get rid of that by doing a power of 6 on both sides, and I get 729 equals g. Okay? Now this one is another beast to check, all right? And it's another one that I'm going to do side by side just so that you can see the difference between the two. Let me clear them both so you can see. Okay, so where's my problem here? So I want to start with the 6th root of g. So 6th root of 729 plus 9. So on this calculator, if I don't put it in parentheses, then your calculator is only applying the root to the 729, which is what we want it to do based on how this is written. We only want the 729 under there, okay? And that comes out to be 12, all right? On this one, I don't have a regular number over here. I have like another math expression. So I'm going to have to do the math on that other side and figure out if that also equals 12. So 4 times, whoops, forgot my 6. The 6th root of 729. And that also equals 12. So that means I'm good to go. Okay, my two sides of the equation are equal. On this calculator, I'm going to do the 6th root of 729 to start out with, just like I did before. But what I need to be careful of here, we said this is an advantage a minute ago, but now we have to be careful about it. I want to make sure my plus 9 does not end up underneath the radical, right? This plus 9 is not supposed to be underneath the root. And if I just type it in right now, it's going to be. So that little blinking arrow is telling you that if you push your arrow button to the right, it's going to cut off your root. See how it's now everything I type is going to be outside of the radical? So now I can go ahead and hit my plus 9, and the 9 does not end up underneath the radical. That's important. Okay, hit enter, I get 12. Okay, let's try the other one. So 4 times the 6th root of 729, and I also get 12. Okay, so again, there's just a side-by-side comparison of what one calculator looks like versus the other. And it's important for you to know which one you're dealing with. If it's your own personal calculator, you can kind of get accustomed to it. If you're borrowing one of mine every day, some of mine look like this and some of mine look like this, so you really do have to adapt to both. Okay. But that's really it for today. None of the math is too terribly difficult. It really is just that last step about checking your answers that's going to catch you a little bit. Okay, so make sure you're just diligent about that. And then we'll go over this assignment tomorrow before we dive into the rest of Chapter 8.